Start class today with this warm-up problem. Press pause on the video, and when you're ready for the answers, press play again. Here are the answers to the problems. In the first problem, it is a cosine curve, and you can see that it has been shifted up 2. That is why D is 2. And A is also 2. It is the distance between my transformed x-axis and the minimum or the maximum, so 2 away. B is 2 pi divided by the period. My period is pi over 2 minus a negative pi over 2, so that's pi. So 2 pi over pi is 2. And you can see cosine starts up in amplitude, so it has been shifted to the left, pi over 2. So that makes a positive C value. So when you write out your equation, it should look like that. We're supposed to determine the range of the function without graphing. So if you think about the range of the parent function for secant range is negative infinity to negative 1 and 1 to infinity. To this, we multiply by A and we add D, and I multiplied by the absolute value of A. End up there. We're going to determine the domain of cosecant without graphing. So the parent function domain for cosecant is all reals where x is not equal to k pi. To this, we divide by b. B here is 2. And then we subtract c. C is pi. So this ends up being my domain for my cosecant function. Today we are going to graph tangent and cotangent. What I'd like you to do is fill in the values for each of these functions here. Notice that for my x's, the x's that I'm evaluating for tangent are different than normal. They start at negative pi over 2. They go to positive pi over 2. For cotangent's different. I'm starting at 0 and going to pi. You'll see why in a few moments. So take a minute, write that in your notes, press pause on the video, and when you're ready for the answer, press play again. So this is what you should have. At negative pi over 2, remember tangent's y over x. Y over x here is undefined. At negative pi over 2, y is negative 1 and x is 0. And you should get these values. Cotangent is x over y, and the values are here. Get those from your unit circle. Now I want to talk about what tangent looks like. You're going to have to copy this in your notes. So this is going to be my parent function for tangent. Remember that an undefined value is a vertical asymptote. So at negative pi over 2 and positive pi over 2, I have vertical asymptotes. I've plotted values. Here at negative pi over 4, I have a negative 1, 0, 0, and pi over 4, 1. Then my curve gets drawn like this. The period of tangent is pi. The amplitude is none. The domain is everywhere except where I have an asymptote. So I'm going to have an asymptote, in this case, every period. So my domain is all reals, where something's going on here. Hold on. My domain is all reals, where x is not equal to an asymptote, pi over 2 plus k pi. My range goes from negative infinity to infinity. Next, I'd like to see what cotangent looks like. And before I do that, just notice that whenever we graph tangent, we're going to be graphing it between asymptotes. So I want to see one continuous graph here. Cotangent looks like this. So I have my asymptotes at x equals 0 and x equals pi. I have divided my interval up into quarters. At pi over 4, cotangent's 1 at pi over 2, cotangent's 0 at 3 pi over 4, cotangent's -1, and then I have my curve drawn in here. The period of cotangent is also pi, the amplitude is none, and the domain is all reals except where there's an asymptote, and there is an asymptote every k pi. So right there, every period. My range is -infinity to infinity, just like tangent. Next, we're going to graph tangent, but transformed. So I want you to see how this is done. So let's first identify what A, B, C, and D are. I'm going to make this a little larger. So A here is a half, B is 1, C is pi over 2, and D is -1. So based upon these values, you can see that I'm going to have a vertical shrink. Horizontally, I'll neither be stretching nor shrinking. Horizontally, I will be shifting left pi over 2, and I will be shifting my graph down 1. So I'm going to draw in my axes. Now, I need to figure out where I'm going to graph my function on my x-axis. I don't like how this is looking here. I want to make it a little bit straighter. Okay, so normally I would graph tangent between -pi over 2 and +pi over 2. But I have to take into account any kind of vertical or horizontal stretch shrink and any kind of shift. So to these values I divide by b. In this case, b is 1, so nothing happens. And then I'm going to subtract c. And c here is pi over 2. So I'll subtract pi over 2 from -pi over 2 and get -pi, and subtract pi over 2 from pi over 2 and get 0. So now I'm going to graph cotangent between -pi and 0. The next thing I'm going to do is I'm going to divide this up into quarters. So first I'm going to find my midpoint. It's halfway between 0 and -pi, so that's -pi over 2. Then I have to find two more midpoints. Halfway between 0 and -pi over 2 is -pi over 4. And then halfway between -pi and -pi over 2 is -3 pi over 4. Now, my graph is shifted 1 down. So I'm going to draw in a transformed x-axis 1 down from here. And then I'm going to think about what my tangent graph looks like. I have asymptotes at either end of where I'm graphing. So I'm going to have a vertical asymptote here, and I'm going to have a vertical asymptote here. My tangent graph crosses the wrong place. My tangent graph crosses the x-axis right in the middle of the x values that I am plotting. And then it goes up on the right and down on the left. Now it's going to go up a half, not 1. This is not an amplitude, but it's how far it's stretched or shrunk. And in this case, it's shrunk by a half. So I am going to go, this is -1/2, this is -1. It is going to go up on the right by a half, and it's going to go down on the left by a half. So that would be -3/2 here. And then I'm going to draw in my curve. The period for my graph is going to be the original period for tangent, which is pi, divided by b. In this case, b is 1. So my period stays the same at pi. My amplitude is none. My domain is everywhere except where there's an asymptote. So it's all real numbers where x is not equal to, find the first non-negative asymptote, or any asymptote for that matter. In this case, I'm going to choose 0, and then my period times k. So this is different than secant and cosecant, is your period times k, not half the period times k. Your range is negative infinity to infinity. And that is how you graph tangent. Let's graph cotangent ones. So, oops, I'm going to make this larger. So I'm going to draw my axes. And then I have to identify what A, B, C, and D are. So I need to factor out the B, so this is equal to 3 cotangent, factor out the 2, x plus pi over 2. So in this case, A is 3, B is 2, C is pi over 2, and D is 0. Now I've got to figure out where to graph. Normally for cotangent, for the parent function, I'd graph between 0 and pi. Now I've got to take each of these and I've got to divide by b. So dividing each of those by 2, I'm now graphing between 0 and pi over 2. And now I've got to shift it. I'm going to shift it by subtracting c. So I'm going to subtract pi over 2 from each of these. I think I'm going to move that y-axis a little bit. Let's see. So now I'm going to be graphing between negative pi over 2 and 0. Just like with tangent and with sine and with cosine and with secant and cosecant, I need to find the midpoint of my interval. So this would occur at negative pi over 4, and then I find 2 more midpoints, negative pi over 8 and negative 3 pi over 8. I have to know what cotangent looks like, and I'm going to have asymptotes at either end of the values that I'm plotting on my x-axis. So I'm going to have an asymptote here, vertical, and I'm going to have another asymptote here, also vertical. Now, my graph has not shifted up or down, so I'm going to have a value for cotangent right smack dab in the middle. Now, normally cotangent goes up on the left and down on the right, and in this case, since it's not reflected, it's going to do exactly that. But from this point, the point that is above the negative 3 pi over 8 is going to be 3 above it rather than 1. It's not an amplitude, but it is my stretch strength factor, and in this case, it has stretched. So it's going to be up 3 over here and down 3 over here, and then we're going to draw in the curve. My period is the period of my non-transformed graph, or my parent function for cotangent, pi divided by b. So my period is pi over 2. The amplitude is none. The domain is everywhere except where there's an asymptote. So it's going to be all reals where x is not equal to an asymptote. I have my first non-negative asymptote at 0 plus the period times k. So x is not equal to 0 plus k times my period, k pi over 2. Then the range is negative infinity to infinity. Now I want you to take a few minutes and I'd like you to graph this function. Press pause on the video, and when you're ready for the answer, press play again. Here is my answer. You will notice that I have plotted my function between 2 and 4. I got those values, over here. So I normally graph tangent between negative pi over 2 and positive pi over 2. To each of these, I divided by b, and b in this case was pi over 2, and then I subtracted c, and c in this case was negative 3, so I was adding 3. So that means I'm graphing between 2 and 4. Then I drew those values on my x-axis, and I found my midpoint, which was 3, and I found 2 more midpoints here and here. Then I noticed that my graph is shifted up 2, so I drew in a transformed x-axis, and I knew that tangent normally goes up on the right and down on the left. However, my a value is negative, so it is reflected. So I have a value right in the middle at my transformed x-axis. It went up on the left, 1, the absolute value of a, and down on the right, 1. And then I drew in my curve. Now, the period is pi, the non-transformed version for tangent, my parent function period, divided by b, which was pi over 2. So my period is 2. The amplitude for tangent's none, since there is not a max nor a min. My domain, I picked out an asymptote. In this case, I picked out 2. And I added my period times k. And then my range is all reals. Now I'd like you to do the assignment that I have posted online.